Cool. So, hello everyone. Welcome to the second webinar in course of the hackathon we are holding for the Cardano Summit that's happening in November. I'm super happy that so many of you already have signed up for the hackathon. It's quite a lot of teams that are already participating. For today's session, it's actually pretty relaxing for me because I will just hand over to two of my dear colleagues that will provide you with an overview on the one hand about how to connect a wallet to your web application. That will be done by Fabian in the first part of today's presentation. And then we have Mateusz, also well known from the Cardano fan stake pool and community group that should be well known actually in the ecosystem. And he will give us some insights into how to use the Aiken smart contract platform to write smart contracts or validators for Cardano. So without any further ado, I'd like to hand over to Fabian. Please take it away.
Hey, hello. Can you hear me properly? Guess so.
Sounds good.
Okay, that's good because I had some connection issues as well. Yeah, thank you. I will try to share my screen. How do I do this in Zoom? Is there a button for it somehow?
Yes, on the lower part of the screen, there's screen. It would.
Ah, sorry. Yeah. Um, got it. So then let me share the presentation. Okay. Can you see my screen?
Yes.
Okay, super. Then I will just start. I don't know if it works in slideshow mode.
Looks good. Looks good, Fabian.
But good. Okay, yeah. Then thank you for participating in the workshop. Today I want to show you or give you a little overview over a few tools. So the slide is called Fantastic Tools and where to find them. The answer is pretty simple. We have this developer portal under https developers.cardano.org. Please go to this site and then you have a getting started section to get familiar with Cardano, the builder tools and showcase. So you can find anything if what you want there, but to give you a little more insights and to highlight some of the tools, I want to show you today Blockfrost and Koios to query data from the blockchain, and then also Mesh.js, which has pretty good starters and button components, also a connector to create and assign transactions in the front end. And then I want to showcase the Cardano Connect with wallet. I called it Star because it was the Cardano Connect with Wallet button a few months ago, but it iterated to a library that also offers a core library and the pure JavaScript library for those of you that don't use React in your front end stack. So, and then I want to quickly showcase, but I guess Matti will also show that or mention that Yasi Dev Kit, and then two libraries for signature validation in backend or frontend. And then I will quickly jump to the CIP8, which is mainly for signing the messages, and CIP30, which is the dApp and wallet connector bridge, and then SIP45, which is still in draft mode, but it's a CIP, so Cardano Improvement Proposal from the Cardano Foundation, and it acts like a method to inject an API from one browser to another. I will come to it in a few minutes. So first of all, there's Blockfrost. I think many of you, if you ever worked in the Cardano ecosystem, are familiar with Blockfrost. I also wrote a few apps that uses that using the BlockFrost API to query information such as NFT information, wallet information, token information from BlockFrost. I in my spare time application that I write, I switched to Koios because it has one advantage over BlockFrost. You do not need an API key. So if you decide to go with BlockFrost, all good. BlockFrost is great. Make sure you hide your API key in a proxy application or in a small backend proxy or whatever to not make it go live with your dApp to the public. If you go with Koios, Koios is a community service that offers an API to the blockchain, so you can just use it. There's an API limit, I guess, but it's very high. I never reached it, and it's run by different community members. It's very cool. I hope this link works. No, it does not. Maybe if I go here, okay. Then let me just copy paste that. Um, so I have linked here an example. For example, I wrote this get stake address from ADA handle function in TypeScript, where you put an ADA handle as a string in and you get the stake address out. And this can be done by using two Koios API calls. The first is you get the policy. You need the policy ID of the ADA handle, which is fixed, and you can get it from the ADA handle documentation, and then the asset name, which is your ADA handle. So if you decide to buy my crazy ADA handle, and
Can
you want,
Fabian, can you make it a little bit bigger because
yeah, sorry,
it's not readable, like
yeah,
Command Plus or something.
yeah, I will check. Um,
Command Plus.
command exclamation mark, is it for me? Oh no, it's not.
Yeah, okay. You have a
Um,
different keyboard here. That's okay.
yeah, different keyboard layout. I have a Swiss one actually. So let me check. Is it better now, or
Yeah.
comes it
Yes,
better?
it's more.
Yeah.
Yes, definitely.
Okay, that's good. Um, so what is this application about? It's open source, so you can walk in wallet. You can go to the sources in GitHub. Under my GitHub user Fabian Bormann, just my name together. I was not that creative, but you can go to Walk in Wallet and it will display all NFTs in a auto-generated 3D room. And you can just walk through this 3D gallery. And there I use Koios because it allows me to only run the front end. I deployed it for free in Firebase, for example, so I only deployed the static front end, and I have no costs to maintain the app. So you can use this Koios calls. They are very mighty to get the asset holder, and then the next step is to get the stake address of the payment address. If you go to the Koios documentation, I think I need to scale up again, but it's available under api.koios.rest, and then you get a list of all the possibilities that you can do with Koios. Many of them are very identical to the BlockFrost API. Others give you also the possibility to make a bulk request of something, which is sometimes very helpful. So take a look. Take a look at transactions, blocks, addresses, assets, whatever fits your need, and then it should help you when you create your dApp. So the next thing that I want to show you is Mesh.js. I also will just copy paste that one to make sure that I end up on the right page. So Mesh.js is very great for TypeScript developers. It gives you a lot of blueprints, starters. So I guess I saw that there's a how to start guide and also an npm script that allows you to those starter templates that allows you to spin up a dApp very, very quickly. And you have also the simplified API. So for example, you have this transaction from Mesh Core, and then you can just build a new transaction, give it the Lovelace you want or assets you want, and then you can build it. And with wallet.sign transaction or wallet.submit transaction, your wallet or the selected wallet will pop up, and then let's the user sign the transaction. There is an interesting thing as well. Mesh.js has also the let me make it this bigger as well. Has also a Koios provider, which is kind of a wrapper, and this allows you to also query Koios or make use of Koios in maybe a smarter way than using Axios. Yeah, so this is it. It also gives you a few React components and hooks, and lets you mint and burn assets. So please take a look on Mesh.js and consider to use it in your dApp, because it's very quick, or you're very quick at the goal, so to say, if you go with Mesh.js. The next one is a little bit more. I will show a little bit more. It's the Cardano Connect with wallet button. This was also a React component before. Okay, this works. So what it does, it gives you a React component to wrap SIP8 and SIP30. So SIP8 signing, SIP30 connection. Let me show this to you. We have the storybook, and in the storybook you can interact and check out all the different properties that we have. So typically you would, in your dApp, if you're React base, you would just need to npm install the Cardano Connect with Wallet button and then just use it in your project. The default button shows all the installed wallets, but you can set limits. So if you only want to support for example, Lace, Uroi, and Eternal, then you add them to the list, and they will only show these wallets. If you want to limit the network, in case you want to support only the test nets or the mainnet, then you can also do this with this button component. You can change the primary color to make it more like the look and feel of your dApp, but you can also append custom CSS. I also did this for Walk and Wallet, and I think I also linked this. Yeah. So this is everything you need. In this case, I have this custom CSS, and it uses styled components with the CSS style first, and then your CSS will be injected last, or the custom CSS will inject it last, so that you're able to override every CSS coming with this button component. So you can customize it in every way you want. For example, here it looks like this. But for Cardano Ballot, the voting application that we wrote last year looks like this. So you can adjust it in the way you want. One special thing about this button component and why I want to showcase it is that it also brings this P2P connect which is SIP, or better known as this SIP45, and it allows you to connect with wallets that are compliant to the SIP45 standard. Currently, Eternal has its beta phase, and it would be cool if you would play around with SIP45 as well, because just it makes a lot of fun. This is the first thing, and the second thing is to give us maybe also feedback about if it was easy to use, or if there is a blocker, or about something that does not work yet. So this would be very cool. You can, per default, it's disabled yet, but you can enable it by peer connect enabled, and you can set it to true, and then it will show this P2P wallet button as well. So yeah, I said this one is the React component, but we had a lot of requests in the past to also support other frameworks like Vue.js or Angular, and that's why we decided to rewrite this component, which we finished 2 weeks ago, 3 weeks ago or something. So it's now split it up in two libraries. It's the first one is Cardano Connect with Wallet, and the second one is Cardano Connect with Wallet Core. So if you go to the GitHub page, for example, you will see this React and this core component. And the core component it comes with the same feature like the React button, but without UI. So you would need to, if you want to use it in Vue.js or in some other framework, you would need to write your own API and then make use of the functions in the core components. But it makes a lot of sense to use this core component because it gives you, for example, a sync between your instances. I can show this. I can show it in this. So this is the Cardano HTML dep. It's an example dep that makes use of the Cardano Connect with Wallet core, and the source code is, if you go to HTML, then it's in index HTML. So it's just the plain CSS, HTML, and JavaScript lib, very small, and only as an example to show that it's possible without any framework now to use this core component and to build up the buttons. So if you click on Eternal and connect to Eternal, you will see that all of these instances are synced. This is because the core component uses an observer pattern and observes all the instances in your dApp, which is very useful if you want to query a state on the one side of your app or on the other side of the app. The same is works for the React component. So if you use our hooks, wait for it, if you use our hooks, so if you don't want to go with a button, but maybe in React with the hooks, then you can use Cardano, and it will also, as you can see, it uses the core library, and it will also have this observer pattern from the core library. So it gives you the wallet name, for example, enabled wallet, but also the stake address and the balance. And you can configure the button to show, for example, the balance. We're working on an ADA handle support. Matti mentioned this issue a few days ago. I will tackle it as soon as possible. And for now, it shows the stake address or the balance. But you can also use this use Cardano hook in some other part of your application. So for example, you have your main page, and there you have the button component, and you connect to Flint or any other wallet, for example. Then you will, if you're on the other part of your application, you say use Cardano and you can get this enabled wallet from here, then it will be synced between the button and this use with Cardano instance or use Cardano instance. With this enabled wallet, you can feed, for example, Mesh.js transaction builder. As I showed you, it wants to have a wallet name. So here, await wallet sign transaction. You can use this wallet and put it in here, like Cardano dot and then the wallet name or the API, and then it will call the sign transaction. So you can combine both the button, the hook, and Mesh.js. Yeah, let's come back to the slides. So the next thing that I want to show you is Yassi Dev Kit, and it's built by a colleague of us mainly in his spare time or in his spare time. It's Yassi Dev Kit. In my part, I only want to talk about dApps. That's why it's maybe a bit strange that I want to show Yassi Dev Kit, but it makes sense because Yassi Dev Kit allows you to spin up a local Cardano network on your PC without having any test net evolved, or you don't need to get some test ADA or something. You can just spin up a Cardano network with basic components like a basic Explorer, so developer Explorer, and so on. And it provides an API similar or identically to Blockfrost, which is also very cool and helpful if you're developing it locally. That's it. And if you want to use a Cardano node in your setup, I just want to mention that while it's very straightforward to follow the developer tools and then the guidelines to bring up a Cardano node, I simplified it by having these Cardano node UI. So also under my GitHub user, just go to the Cardano node UI. It's open source. You can download it for OS X, Linux, Windows. It brings up a small Electron application. You can select the network, then just click start, and the download, the configuration part, all of the steps mentioned in the developer portal in the getting started section will be done automatically. It will give you the output in this terminal look-like component, and then you can just copy the socket part and put it as in your environment file above. So it's helpful if you want to work with the Cardano node in your setup as well. So for signature validation, imagine you have this Cardano connect button and you want to sign a message. So for example, I think, yeah. So I want to sign a message. I click here, and then there's this message. I click sign, and then I have as an output the signature. If your app relies on that the user signs content and you want to validate if this content really comes from this address or was signed by this address with its keys, then you can use the signature validation modules that I will show you in a bit. So if you're now coming up with the question, how can I enable sign a message? It's you have this onSign message method which you can override. Per default, it will print it out somewhere, but you have also a message here, and you can change this to my validation or welcome user. By signing this message, you make sure that you're accepting my terms and conditions. I don't know. And it will be displayed here. I don't know if you see the pop-up, but it will be displayed in Nami wallet or in Eternal. And then the user can sign it, and within the on-sign message, you can then send the signature to your backend or do whatever you want with it to validate it. and to check if it really comes from this address. So we have two libraries for the signature validation. The first one is Java-based. So if your backend is Java-based, then there's this library mainly written by Matti, and you can just use it in your project. And here's also an example usage of how you can validate the signature. And the other library is TypeScript based, so you can also use it in front end. I don't know if there's a use case for it, but you can also use it in front end or in your Node.js backend if you need. So here's also an example of how to use it. Key and signature. This is the output coming from your from this on-sign message method that you would need to override, and then you can send this to your backend. Message is the original message that the user signed, and address is the address. You can also get it from the hook and then send those four things to your backend. Then you can just use the verify data signature function. You can check it with the message, without the message. So only if the key in the signature is valid and matches to the signature. So if the key is within the signature, or you can also add this address as well. There are a few possibilities. Please check out and reach out to me if there is any question. Just open a pull request or an issue, and then maybe we do together pull request, but just open an issue here or a discussion in the Cardano Connect with Wallet button icon button. So, okay. The next things is about SIP30, SIP8, and SIP45. SIP30. So in Cardano, we're working with Cardano improvement proposals. So if you have any idea to make the Cardano ecosystem better in whatever aspect, then please reach out to that repository, read about the SIPs and its possibilities, and then you can start to write a Cardano improvement proposal. One of it was the SIP30, and SIP30 is the main wallet and dApp connector bridge. So everything that I showed you in high level, like the button component, like the mesh libraries, and so on, is built up on this API. It's a spec, so the wallets needs to implement them or needs to implement that spec, and then it can be used like Cardano, wallet name, and so on. This is the explanation how it should look like. If you want to see how it looks like, then you can just open, oh, don't know why, but open the DevTools, for example. Then go to your console and do a window.cardano. And if you have any SIP30 compliance wallet, any SIP30 compliant wallet installed, after having window.cardano, you should see those wallets in a list like Flint, Eternal. I think it's very small. I don't know if I can make the DevTools larger, maybe by changing the window size. Is it larger now, Matti?
It's readable.
It's readable.
At least
okay.
For me, yeah.
Okay. So there you can see there's Eternal, Flint, Lace, Nami, all the wallets that I have installed as browser extensions. And if you click on Eternal, then you can see that it matches this explanation in this in this SIP. So enable gives or returns the API, and the API itself contains then all these functions like is enabled, AP version, and so on. So all that I showed you previously is maybe a wrapper or a nicer look to those basic usage. You can also decide to go with your window object, but I think if you write a React app or Vue or whatever, then you have better options out there, or smarter options. But this is the basic. So, and also if you call this sign message, like sign transaction, sign data, then those are compliant to SIP8. And SIP8 is about the signature or the signing method in Cardano, and the verification part. So again, you don't need to. This is just background knowledge. If you're fine with the button component or the components from Mesh.js or the core lib, then you don't need to read deep into the SIPs. But it's nice to know that the signature and validation is SIP8 and the wallet and dApp connector is SIP30. There's also this other SIP that I mentioned. It's SIP45. That I showed you within the button component. So it's not merged yet. That's why it's in a branch, and it's the decentralized WebRTC dApp wallet communication. It's a very lightweight way to inject an API from a browser to another browser. So if you want to play around with it, I think there are more use cases than just a wallet dApp connector. But here it fits very good for a wallet dApp connector, because if you're on mobile, you typically don't have any browser extensions installed in your mobile Chrome. So if you go to JPEG Store or whatever tool in the Cardano ecosystem or dApp in the Cardano ecosystem, and they have a wallet connector, you will see that only a few wallets are available in mobile, and they all come up with their own implementation, or meanwhile, DC Spark also implemented Wallet Connect. But when we wrote this SIP, there was no Wallet Connect in Cardano available, and the SIP offers is so-called lightweight way. So we are not using signaling servers. We are using torrent trackers to make the peer discovery happen. So if you have two browsers and you want to have a direct communication channel via WebRTC between those browsers, then they need to find each other. So if you're on mobile and in Wi-Fi or on cellular network, and you're having your PC in front of you in your Wi-Fi, and you want to have both browsers have direct communication, then they need to resolve their IP addresses to get an exchange or make an exchange happen. And Wallet Connect uses a signaling server for that, or signaling servers. So you need to add code to your dApp, and you need to have, I think it's an account at Wallet Connect, and then you're able to use their signaling service, or you can also bring your own. But in this case, it's mainly about the protocol level. So with this SIP45, you're able to offer under the hood. It's offering a torrent, but there is no thing you can download. It just uses torrent tracker to make the peer discovery happen. So there's no central signaling server evolved. You have a list of torrent trackers, and then you're leveraging the existing torrent infrastructure to make this communication happen, and then you can just start the communication via WebRTC. And you don't need to do anything of it, because the button component does everything. So if you see this P2P button, for example, or in Walk and Wallet, if you see this P2P option, which you can enable, then you see that here's an address, and you can scan it with your eternal smartphone with your Eternal app on your smartphone, and then it will start the connection. So if you want that your dApp supports mobile without having a Wallet Connect or other solutions, then this is the fastest solution, I would say. Just use the button component, enable it, or use the core component, the core library, and enable it in your API, UI, sorry. And that's it. If you want to play around with it, then there's this Cardano Peer Connect library, also under my user. We want to move this in the future. And here you have this Cardano Peer Connect, which is for wallets. So it's an abstract class, so to say, and wallets can implement it, and then they need to override the SIP30 functions. So essentially, the one browser, the wallet, injects its SIP30 API in the other in the dApp. It could also inject the Wallet Connect API or anything else, a chat API, whatever. And then you have this dApp Peer Connect, which is a class used by dApps, and this also gives you logging, and then it has already the tracker URLs configured, so you can also use that. I used it in the button component. So if you go with the button component, you don't need to use it. If you go with the core library, you don't need to use it. If you want to use it and play around, reach out to that repository and then have fun. I think this was it from my side. I hope I left enough time for you, Matti.
Yeah.
So sorry.
20 minutes left, I guess.
Okay.
No, we're doing actually in 90 minutes.
Okay,
Yes.
90 minutes. Okay,
Then it's good.
That's good. Yeah.
Okay, then I would overhand to Matti, and thank you. Reach out to me if you have any question. Please put them in the chat. Do we want to make a break here and go over the questions, or do we want to go over the questions after the call or after Matti's part?
I'd say we start right now, because so far the questions that came off with, we replied to them already via chat.
Okay.
Maybe
Cool.
you can have a look at the chat messages again and get back to some of the questions.
Okay, cool. Let me check.
And I'd say, Mateusz, you can take it away.
Okay.
Yeah.
Let me share my screen. Sorry.
Thank you for listening. See you.
Okay, hopefully you can see my screen now with the Aiken Lucid Yassi Dev Kit Starter Kit. So what just a little agenda maybe for what I will present. So I will present to you a relatively simple Aiken contract. The goal here is not to become, it's not enough time basically to become like an expert in Aiken or anything like this. It will take some time, although I think learning curve for Aiken is relatively flat comparing to Plutus TX. Nevertheless, still requires some time. So the main goal is to present a quick way to develop on Cardano with Aiken. I personally use this during my daily activities quite a lot. And I would even go as far as I cannot imagine at the moment not having those tools for to develop on Cardano. It's addictive, I would say, or smoothens the development experience significantly. Maybe that's a better way to say that. So as Fabian already mentioned, there is this product called Yassi Dev Kit, and it will be important part of this presentation. So we were gonna use Aiken, we're gonna use Lucid, and we're gonna use YASI DevKit. And for this, I already shared the link. I can share again because it was some time ago to this repository on the chat. Sorry, let me just do that so that you can follow this. This is actually one of our first templates that we as Cardano Foundation have released. That doesn't mean it's the latest, but one of the first templates to help like develop on Cardano. And in here, there is a presentation from our Mateusz Czeladka. Some of you might already know him under the nickname Knorrs. So feel free to watch it if you would like to dive deeper into Aiken a little bit on its goals and so on and so forth. We will not have time, unfortunately, to go through this presentation. And then you can open this this link to a public tutorial, which is pretty much this one, yeah, and then it goes step by step exactly what is necessary to build on Aiken with YASI DevKit. So yeah, so that's what we will talk about, and if there is time, I will be happy to answer some questions related to this setup, and maybe even some Aiken questions if they are not too difficult. I'm not an expert in Aiken, but I definitely can do some things. And I also will show you some absolutely brand new things that we are working on with YASI DevKit if there is time, which even more improves the development experience and performance, I would say. So that will be a little bit sneak peek at the end towards where we're going with some things. Okay, so without further ado, let's try to run this together by following this tutorial. And so you need to have Docker installed. And on Mac, you can basically have like Docker Desktop. Simply install Docker Desktop and you should be good to go. So I already have it. You should also have Git, which ships already with macOS. You might install a newer version of Git if you want, but yeah, you just need to have Git. I mean, it's kind of like no-brainer, I would say, for developers. Now, if you're running from Linux, some of the commands in this particular application, they have really, sorry, tutorial, not application, have not been geared towards Linux users, because in Linux, typically you have to run Docker with sudo. So I linked just some tutorial how you can make Docker sudo-less, basically, without necessity to type sudo each time and run as root. Otherwise, I would have to always, every single command, I would have to say, but Linux user have to do that, badly, right? So, so this is how I solved that problem. Like Fabian already mentioned, so YASI DevKit is a local Cardano network. For those of you that have been building on Ethereum, you might have heard of a product called Ganache, which is pretty much the same. They just maybe it's more obviously more developed because they were working a little bit longer on that. YASI DevKit is still very actively developed and new features are coming in. Nevertheless, you can be very productive already with YASI DevKit, so it's not like it's not ready. It's just some maybe extra bells and whistles can be added. Yeah, it's not really like really layer one where you have 20 seconds, but you have 1 second block time on average. And even on Cardano layer one is also on average 20 seconds for those of you that are not aware. Sometimes it's 15, sometimes it's 20 something, right? So it's on average 20 seconds. Now, the reason for this is because we want to have a very snappy and quick development experience. We don't want to submit our invocation of the smart contract, or in fact, anything, you can use it also metadata transactions and so on and so forth, and then having to wait. It's very important as a developer to have quick feedback cycles, not having to wait for a long time, basically, to see some response. Now, this doesn't sound much, 20 seconds, but if you want to really fast iterate over something, then even this 20 seconds can slow you down in development. So that's why it's by default 1 second. So it's not really a replacement for a pre-prod environment. Like if you really want to go on the mainnet, you should still have the like a final testnet. But during the development phase, there are not really a lot of cases where this 1 second plays a role, but there might be some cases for the final application on the mainnet. Yeah, so it's not a replacement for the pre-prod environment or a preview environment and so on and so forth, the official Cardano testing environment. About Aiken, so Aiken is a modern smart contract programming language, takes a different view slightly to some other tools in the Cardano ecosystem. It's relatively simple functional programming language, contrary to Haskell or even Plutus TX, which is a DSL from Haskell, which is actually a subset of Haskell. And yeah, it's relatively simple. It's actually a derived language from a language called Gleam. Many of you probably never heard of it, but it's a very actually interesting functional programming language. And a lot of design in the Aiken has been inspired by Gleam and simplicity of Gleam, basically. Yeah, what else? Yeah, that's pretty much on Aiken. You can read more details. And yeah, somebody pointed on the chat. This is true. It's not just Gleam. It has been inspired by other languages as well. But there is, yeah, Elixir and I think even from Rust to some extent, there are some inspirations. But contrary to a lot of people's popular opinion, is not a copy of Rust by any means. So this is a fully functional language, and Rust is not fully functional language. With Rust, you can have mutability. Yeah, quite typically, actually, you have mutability with Rust because it's a systems programming language, right? So systems programming language typically have mutability. Yeah, Lucid. So Lucid probably doesn't need to be introduced, but there might be some people that are new to Cardano here, so I will do this. It's a library developed in TypeScript by one Cardano community member, which gained a huge popularity because it's very good, very powerful, and works like a charm, typically. However, it's not the only choice. There are other choices. Just this tutorial uses it in Java. When we are developing, we have also a Plutus application backend. There is one in Haskell called Atlas. This is also a very good product. Yeah, there are a few alternatives to Lucid. Okay, so what you have to do, you have to clone the repository of the Yassi dev kit itself. I am at the moment on a branch with some new features called develop. Of course, you can also switch to that branch if you want to. It's not like it's a public repository and it's a public branch, but if you want to be on the mainnet, you can be on the, sorry, if you want to be on the main branch, you can also be. So there are just a couple of new features in the develop branch. So yeah, you have to make sure that that it's startable, basically, and then we can launch it. Now, what the start command will do, no mysteries here. It will just, it's a wrapper around Docker Compose, yeah. So you need to, the latest versions, yeah, make it bigger, sorry, yeah. The latest version, hopefully this is already enough. The newer version of the Docker Compose, Docker for Mac, they already ship with Docker Compose, so you should be good to go. On Linux, you might, I actually don't remember. You might actually have to check if you have Docker Compose. You might need to extra install it. And older versions here of the desktop, the Docker desktop, they didn't ship with Docker Compose, but yeah. So there is no magic. It's just pretty much a wrapper around Docker Compose, plus it prints some URLs how you can access some things. So it's actually started and I launched it. This was very quick for me, obviously, because all the Docker images and everything, they are already downloaded. But typically on your machine, it will take a little bit of time to download some of the Docker images running to start. Okay, so once we do that, let's have a look at the Yassi viewer, which Fabian also very briefly was talking about. It's sorry, this will not work yet because I have to actually start the Cardano node. For that, there is a Yassi CLI command like this. And then you just have to go and say, create cluster -o means override and -- start. So we will create one stateful operator cluster and we will immediately start it. That's what I typically do when developing locally. Yeah, there is one, yeah, as I already mentioned, there is one stateful only, and one Cardano node. Okay, now that it started, then Yassi viewer, it's a very simple Cardano blockchain explorer developed in Svelte, not React, but Svelte. But this is like a small technical detail. And as you can see, yeah, the blocks are created relatively every second, like I already mentioned. No transactions at the moment because nothing is happening. But those transactions that you can see on the right-hand side, I think they are related to the top-up, basically. And because you can top up individual addresses, so you can inspect the transaction, or at least you should be able to. Okay, maybe I have some cached version because this is really strange, to be honest. That sorry,
some methods are on epoch end, and then they do there's an aggregation on epoch end. Maybe you need to wait for an epoch.
Yeah, but I have reset it. Okay, it's always the demo thing here, right? So when you are in the demo mode, okay, I don't know why this is not. Maybe because I'm on develop branch. So I will talk to we will have a look at that. On main branch there shouldn't be any problems. Okay, and then as I already mentioned, we need to start this Yassi CLI tool. You can also get a little bit of help of what commands are available here. You can, for instance, check the latest tip. You don't really need to use Yassi viewer for it, so you can see that the blockchain is progressing. The Cardano. This is actually the Haskell instance of Cardano. This is not like we wrote at the moment some alternative implementation. It's just via Docker we are starting one Cardano node via Haskell. There is also environment file. And in the environment file, you can specify if you want to automatically top up certain accounts.
Mateusz?
Yeah.
Sorry for interrupting you, but can you make the text a bit bigger?
Yeah, I already anticipated what you wanted to say. So
yeah, I saw it. I already saw it. That's great. That looks better now. Thanks.
Yeah, maybe this is now too big. So you can basically specify which addresses you want to top up. So this is quite good for for a lot of use cases. For some use cases, you might want to actually automate this process, and I will be showing this at the end of the hackathon or presentation for the hackathon or tutorial for the hackathon, how actually you can programmatically do some of these things with Yassi. So for what I'm personally doing at the moment at CF, this method was not good enough. I needed to have more programmability with Yassi rather than using some property file. Okay, but for a lot of for beginning, I would recommend this method. It's the simplest method to start with. Yeah, I already mentioned create cluster. So we started the cluster already. So we went through that, and you can also inspect some UTXOs here, basically, on a particular address. So you can have a look. For instance, if you have topped up some wallet, if this wallet has UTXOs, how many UTXOs it has, and so on and so forth, right? Cardano, contrary to Ethereum, effectively under one address can have multiple UTXOs. Multiple UTXOs, and even then there are even multiple further. It's like a tree structure effectively. Here you can see this is actually the first one out of this UTXO. But anyway, let's not overcomplicate it right now. So the unit is Lovelace. Please don't be fooled. So you need to divide this by 1 million, obviously, to get 1 ADA. 1 ADA equals 1 million Lovelaces. Yassi viewer, I already showed it roughly how it works. And then we are ready to check out to clone another repository, the Meter Aiken Lucid Yassi DevKits starter, which I already have in another window here. Hopefully this is big enough and this is visible. And here we actually have our smart contract. The invocation of the smart contract. We also have some Aiken files here and a very important file called plutus.json, which contains the actual smart contract, compiled smart contract. Now, when you are developing, or when you will be developing, typically you can use a few methods. I would recommend to start with a website called play.aiken.lang. Because it's easiest to actually get yourself dirty with this. You don't really need to install much. You have everything already here. Actually, everything apart from one feature, which I requested to the Aiken team to develop it. So you can format the code, you can check the code, you can share the code, but you actually cannot compile the code right now, at least from the playground. So that's for that you will actually need to install a Visual Studio Code, or you can just install Aiken via Aiken app. There are a few methods on the website which are documented how you can do this. I personally compile with Cargo, so I typically go Cargo install. I think there was some. Cargo. So you can do it basically like that. You just need to pass the latest version. Let's say, I don't know what is the latest one right now. I think Alpha 11 or something like that. Let's have Alpha 13 is already the latest. Yeah. So you can do it simply like this if you want to install it locally. With a released version. But for starters, this is good at least to play around with it, understand a little bit the syntax, and so on and so forth. All right, where were we? Yeah, on the Visual Studio Code side of the things, you can install Aiken with with extensions. So you go into extensions, and then you will find a language, Aiken language support for Visual Studio Code. So I have already this installed, and but please don't be fooled. And this is, I think, a mistake that is easy to make. This actually doesn't install Aiken itself. So you should have Aiken installed separately. And this basically will reference the Aiken available in the path. So if I now launch this in the Visual Studio Code, then we can go to the Hello World contract. And then, as you can see, there is nice formatting, and there is syntax highlighting, and so on and so forth. So if I make a mistake, there should be it should complain. It's complaining here that yeah, there is some lexical error, syntactic error basically. And then if you want to compile this, you just type Aiken build, and then it will build it. Or Aiken check. If there are some errors, or if you have some unit tests, then Aiken check will verify them and will also tell you what is the execution unit cost, which is a very nice feature. This one is actually demonstrated, I think, here. If we run check here, then you can see what the check typically does. Here we don't have unit tests, no property test or anything like that. It's a beginning session, right? And as you can see, these ones are the CPU units, and these are the memory units for quick sort here. So this is actually very handy. Yeah, this functionality for the CPU units and memory units. If I would copy this contract here, just for fun at the moment, then obviously we can also, oh, sorry, I have to save it. Visual Studio Code, you have to save it. Yeah. So this is actually how it looks like, right? It will give you such a output. But let's go back to the previous version. So yeah, where were we? There are also some ways if you want to work with Visual Studio Code with Docker, but don't particularly recommend it. But if somebody wants to play around, then you can do this. What Aiken Playground also supports is a nice feature that you can share to your friend your contract, and you can basically have the contract inside of the URL. And as you can see, this was like a permalink that I have copied and pasted here, and it immediately opens the implementation for our Hello World. So it's maybe not like an IDE that you can collaboratively work together. For that, we are not there yet, I would say, but at least you can send it to your friend with your contract like that. Yeah, there are some alternative here possibilities how to install Aiken, so feel free to follow that. There are multiple methods. You can also compile directly from the main branch, for instance, like that. If you don't want a particular release, if you want to be on the bleeding edge, of course, you can do that. There is also a little utility tool called Aiken App, which is like very similar to, I don't know, Cargo app, or it's like almost like an industry standard right now with this app something, right? I remember seeing this in multiple places, and we also have an Aiken app. So you can also install Aiken via Aiken app way. It's documented on the website. So yeah, you have a curl command here, and it will automatically install it. Okay, so far so good, hopefully, and now we will actually run it. And instead of using, we will be using Dino, which is like an alternative to Node.js, a little bit more secure. And we will run it via Docker. Obviously, you can also run, if you have Dino installed, you don't have to really do it via Docker, but we will use it. We will use Docker because it's the easiest way to start, basically. So I already prepared the command, docker run, as nothing sophisticated, with the working directory of a temp directory. And we will mount this temp directory as a module, basically, and then we will have a host network. This is the actual image. It's not developed by us. It's a publicly available Dino image, basically. And then this is obviously the actual command which is started on the Docker itself, in the Docker container. So let's do it together, and let's see if there will be demo effect or no demo effect, but hopefully not. By the demo effect, I mean that something doesn't work when you have a demo. Yeah, there is of course demo effect, but it's because I need to top up the wallet. I actually have been doing something recently, so okay, let me stop, exit nano environment, and I have to top up wallet. Because there are no funds, I don't have money basically in this wallet, in the wallet that is configured in the application. Yes, it's CLI again, and we will start the container again. Cluster, sorry, one node operator, waiting for the next block. Oh, you see, so this is a top-up command. Actually, I have 3 addresses. I don't remember why, but I have 3 addresses. But one of them, I believe, is the one which is used in this tutorial. Actually, we can verify this. Hopefully, we can verify this. There should be some address here. I didn't paste it. I thought I have this. Yeah. Okay. I think this is one of the addresses. Yeah, this one. Yeah. The last one. Top-up address, which has 10,000 ADA. Obviously, this is fake ADA, right? But has 10,000 ADA. This is that particular wallet. Now, yeah, and now we can rerun this example right here, and with Docker run the same command. So what it will do, it will basically send money to the smart contract. And when money is sent to the smart contract, regardless if whatever you are using on Cardano, Plutus TX, Aiken, or whatever, smart contract is actually not invoked. Smart contract is only invoked when you are withdrawing from the address. That's why on Cardano you have this concept of redeemers. And at first, when I was reading about this some time ago, it's like, why is it called redeemer? I was thinking to myself, it's because you are actually redeeming, you are withdrawing from the contract. So yeah, we just sent something to this contract, and I think maybe because of my broken Yassi, we will not be able to see this, but which transaction was that? And okay, now we can see this, and if we go to the, yeah, so this is the oh no, this is, sorry, the contract of course will not be called, but or maybe this is a top-up command, but definitely it should be here somewhere. Yeah, I think this is the one at the top where we send the funds. Actually, let me double check how much we have been locking. I think we have been locking 1 ADA. Yeah, we are locking 1 ADA. So but we can actually do another method. We can have a look at UTXOs, and then we can have a look what is happening on the address to which we have. Yeah, this is a contract address. Yes, this is the contract address. So let's have a look here. Sorry, of course, here UTXOs, just the wrong window. Yeah, so we can see something locked basically in that contract, and it's a little bit over 1 million, right? Yes, which is a little bit over 1 ADA, because this is in Lovelaces. And then if we go back to the tutorial, so when we launched it, we got actually the transaction ID. when it happened, and we got a datum under which it was logged. So this transaction ID is actually important because we have to find out this datum and we have to unlock basically. The second part of the contract is unlocking the money in the contract. And that's actually when the smart contract is invoked, as I already mentioned. Otherwise, this operation smart contract was not. So there is another Docker command where you can basically unlock it, and you have to pass this transaction ID. And then after this is successful, oh, this is interesting. Why would it fail with an error? I don't know. Maybe because I have compiled the script. Okay, this is again a demo, obviously, demo effect. Let me bring back, oh no, this is exactly the same. I have to think about that for a moment. Why did I copy the wrong one? No, I copied the correct one, the transaction ID. Actually. Maybe I will need to switch away from the develop branch on the YASI. Somebody posts, shouldn't we be using sending the datum? The code is written in such a way that I think, if I remember correctly, the datum is actually looked up from the transaction, but we can verify this. So the answer is generally yes, but the code should already be taking care of this. So this is unlocking. So taking transaction ID. Yeah, this is general instantiation of Lucid. We are passing the Bluetooth file to get the actual compile code from there. And when we are redeeming, we are passing the hello world, which is our secret password, basically. And then there is an unlock command. And we I don't understand why this is not working. I have to say. It doesn't make any sense. This is a very simple contract. We're definitely not overrunning on the budget. That's a bummer. Transaction ID. Yeah, maybe I think maybe I will need to switch to the non-developed branch of YASI. Maybe there is some backwards incompatibility that was introduced. It's the only thing that comes to my mind right now. That's interesting. This is not really. Well, it's another strange thing. Static. Something really strange happened here.
Otherwise, Matti, does it make sense to just show it and mention how it should work? Because
yeah, Yeah, there is some issue, and I will, maybe if there's time we can go over it. I don't know why right now it's not working. I think it's related to the YASI YASI dev kit on the develop branch, because this was already tried multiple times actually. So there's some small thing, yeah. So this is how it should work. And yeah, there's this one ADA that we have locked, and now we unlocked it. And yeah, and that's pretty much it when it comes to the tutorial. And there's some pretty cool contract if you want to experiment on something with Aiken on Cardano. I created this. I call it homework, but it's kind of like a funny term. But it's a dead man's chest contract, where basically one of the common problems in cryptocurrencies is that if we would have some funds and we don't pass our credentials, to somebody, then should we pass away or die, more colloquially, then the money will be lost. And there are many ways, of course, to tackle this problem. This is not absolutely the only way, but this is one way to tackle this problem, and I found it very interesting. And there is a front end, there is a back end, and I encourage you to experiment with this. After, of course, you get after the basics, and if you don't have other ideas to build something, obviously. But I think this is something that really we together as the cryptocurrency community, I will now speak in general, but we need more and more such solutions in case something bad happens to us. We don't certainly want to bury our cryptocurrency forever with us. Now, maybe let me give you a few sneak peeks. So,
Mateusz, before you continue, there's one question in the Q&A part. The question is, are withdrawals and redeeming function only way to trigger a smart contract?
Yes. When you are withdrawing, that's how you typically trigger smart contract. Yes. There are a few contract types, right? We are using the simplest one, which is called spend basically. Sorry, spend type of a contract. But there is a minting contract as well, and there is also like a minting validator, if you will. There is also staking. There are a few of them actually, and one more, I think, withdraw. I think it was called, or something. Well, I don't remember off the top of my head, but I think these are the 4 types of the contract, and they are typically passed in. Sorry, where is our contract? Aiken. Validator. Why is it called validator? Because actually the contract is returning just true or false. Here you can see. That's why we colloquially say that in Cardano we have smart contracts, because otherwise it would be very difficult to communicate in the Cardano ecosystem. But across the different cryptocurrencies, it's like, oh, what do you mean you have smart validators, right? But actually, to be perfectly honest, we have smart validators. We don't have smart contracts in the Ethereum sense. They are passive. They are not active. In Ethereum, the contracts are active with all of the advantages and disadvantages that come out of that. And but anyway, what I wanted to say, and I got myself sidetracked, is here there is this purpose, and we are basically pattern matching on it. And in this case, we are checking if the purpose is spent. And there are, if you go to Aiken, I think I didn't. We can double check that, because off the top of my head I could have made a mistake. What are the other purpose types? So we have to find, basically, we have to go to the transaction package here, and then you can have a look at that. Yeah, there are many repositories in Aiken, so it's actually easy to get lost. But the one which has the language itself is Aiken Lang, I think. Aiken, no, or was it Aiken? Oh. My God, where was the language itself? Set up Aiken app. Aiken UPLC. We could just type. There's another way to find it out. Sorry, where is the depositor? No, this is something else. Where did I have spent? Where did they put it? I haven't recently developed with Aiken. I'm doing actually something else right now. So that's why I'm a little bit myself even lost here. I think it was maybe in the preclude package. Or did the start? No, the preclude. Okay, so this is a standard library. Yeah, but since we are already here, yeah, this is standard library. I will go in and thank you for the comment. But since we are already on the preclude, I think this is something good to mention for people learning Aiken. So there is like these buildings, and this is in the preclude package, and those functions, this is really weird because it's like frozen error here, but actually the implementation, there is an implementation, it's a native implementation of those functions. So this is just like from C, like a header file or something. This is just a definition of the function. That's how you should really look at that. And in terms of standard library, yes, of course. Standard library. So we can go to lib Aiken transaction. And then somewhere here, I think we will have all of those types, spanned and not spanned, so on and so forth. So let me, yeah, in the transaction. Okay. Yeah, there you go. Script purpose. So it can be mint, and then you get a policy ID. It can be spanned, and then you get an output reference of the currently validating UTXO, withdraw from, stake credential again, and publish certificate. So these are the types. Now, these ones are a little bit more advanced. I mean, arguably advanced. Sorry, you need to use them not as often. Although I also have to say that there is also potential to innovate quite a lot in that, because I haven't seen many scripts, validators, which are actually using withdraw from and publish. I've seen much more of this mint and spend. Which, by the way, on Aiken, you can also have something which is called a double validator. So you can be minting and spending in the same script. In Plutus TX, this is not supported. The concept of double validators. But what I also wanted to say, and I think this is something which many people make a mistake, including myself at the beginning when I was learning Aiken. This is like a gotcha. I think this is the right term, gotcha. Trap or the gotcha. So what you need to keep in mind when you look into the Aiken code, that this validator will not run for the whole contract. This validator will run one by one on every single UTXO. So this datum that you're getting here as the first parameter is actually the datum of the UTXO which is currently being validated. Script context is general because that's for the whole transaction. But yeah, you are getting the datum from the first UTXO. And that means that this reference here that we can see, that actually we are not using for anything, it's actually a UTXO which is currently being validated. This was very confusing for me at first, I have to say. So I can imagine that you could also be confused, because I was thinking like, like the whole contract will be validated. But on Cardano, we have extended UTXO. So this script is called every time for every single UTXO. Now, there are sometimes cases where you would want actually in one go to validate everything. Because since you have access to the script context, you can actually, from the script context, look up all of the inputs and all of the outputs. And it's also possible to do it on Cardano, but it's a little bit more advanced, and you need to use like a state machine. You need to use 2 contracts for it. And I'm hoping that in the future, Plutus version 3, 4, we will basically introduce some concept of passing some flag or something that you can say that you want validate for all of the inputs in one go, basically. But right now it goes by every single input one by one and it extracts the data. Yeah, so where was I? Hopefully that answered the question. Now, for a little bit more professional setup, there is also a product called Yassi Cardano Test, which basically you can launch like test containers and you can automate a lot of things. Effectively, this is for integration testing. For Hackathon, I don't know if you really want to go immediately for something like that, but once you want to productionize your applications, definitely a very good thing. Now, we don't have a lot of time left, so I will just maybe at the end introduce you to a little sneak peek what's coming in with the Yassi Dev Kit and what I'm working on right now. And then I will be happy to answer some questions that you might potentially have on the chat. So what I'm at the moment working on is scripting with Yassi Dev Kit. And for that, I have to find the right window. Where did I put it? Oh yeah, I think this is it. Yeah. So so first of all, what is the problem and what is fixed for the problem? So first definition of the problem. The problem is that if we look into this environment file, which I was already showing, there is some top-up command here, top-up property, sorry, and we can top up some address, and then the Yassi network will start and automatically pre-top up this address. But what if we want to do something more sophisticated? What if we want to top up 10,000 addresses? And what if we want to send few transactions? And then we want to automate all of these steps. We don't want to do it manually each time. So for that, something like that is not sufficient enough. What I'm working on at the moment is, and this will be coming with the next Yassi Dev Kit release, is some sort of scripts folder, basically, that you can go into scripts. So I already have it here locally. And there will be some example script that we will provide, and that you can, for instance, that you can learn, that you have a script which is written in, at least this one is written in Amonita. I will tell you why in a moment. Amonita REPL. It's written in Scala because Amonita REPL is a Scala-based REPL. Of course, you could write it in Python. You could do it using some other tool, but I use this one. And the first example that we will provide will be with this one. That we will be committing probably this week to the repository. And yeah, it's just a REPL at the end of the day that launches the Scala. So what you can see in front of your eyes is a Scala program, which invokes basically Yassi for the API. It also, and it has some utility methods basically that were written. And it contains less than 500 lines of code. and it's able to generate like some fake accounts, then serializes some transactions and interacts directly with a Yassi dev kit for automation, basically reasons. Yeah, so it automates working with it. So yeah, that's a bit of a sneak peek to what is coming. Of course, this example is very specific to what I'm currently working on. But the example which we will provide soon will be more generic. It will be like a top-up, creation of an account in a for loop. So like, for instance, you can see here, there's a for loop, 10,000 actually, from 1 till 10,000 it goes. Now, why would somebody need something like that? Well, actually, for what I'm doing at the moment, this is very important because I want to perform a test on if the if the application that I'm working on is behaving on a large number of accounts. It might be behaving correctly on few accounts, which you can test on pre-prod quite easily. You just go and take some ADA from the pre-prod, right? But what if you want to test, let's say, 1 million accounts? What if you want to test 10,000 accounts? That's actually very difficult on the pre-prod network. So Yassi DevKit is a life savior together with a scripting language like Amonita to test your contract. Not just contract, but also some applications that you are working on Cardano with metadata does not necessarily have to be contract for a large number of users. Yeah, so that's what I wanted to give you, like a small sneak peek, and I'm happy to answer some questions if there are some questions.
Mateusz, I think we answered to all questions already, at least from what I can see in the chat. So nothing's left over to cover. I just see a last comment here from Carlos. So yeah, that's it. Thank you very much, Mateusz, for the presentation. Also, thank you for Fabian. Pretty cool. Next week, there will be another webinar, and it will be about an open Ask Me Anything round. So when you already started building on Cardano or you're still fleshing out your solution and are facing some challenges or need some clarification on certain aspects of it, then please note down those questions and bring them to the next session. So that's the end. Thank you very much for attending. And again, thanks to Fabian and Mateusz for presenting everything.
Thank
See
you.
you soon.
Thank you, and